Hello everyone, welcome to my channel GVS Chem. In this video, I am going to explain the product formation during the electrolysis under different conditions. Please subscribe to my channel, like, share and comment my videos.
Now let us discuss the products formed at different electrodes, that is anode and cathode, during the electrolysis. Therefore, products formed during electrolysis. Now, electrolysis of aqueous copper sulfate solution, when copper electrodes are used. Copper electrodes are used. So, first of all, copper sulfate aqueous gives copper sulfate in solution dissociates into ions Cu2 plus ions plus SO4 2 minus ions. Now, reactions at cathode. So cathode means generally copper ions reach to cathode. Cu2 plus 2 electrons give Cu solid. Therefore, what is the E0 cell? E0 cell equal to, that means electrode potential of copper equal to plus 0.34 V. Is there only one ion reaches to cathode? No. There is another possibility of releasing or reducing, and one more also, that is H2O liquid plus it takes electron and become H2 half molecule of hydrogen plus OH minus. E0 electrode potential when the water is reduced at the cathode is minus 0.41 V. Right. Now we studied that ion or atom with higher reduction potential reduces at cathode preferably. Therefore, which ion reduces? Copper. Therefore, copper reduces at cathode. Now let us discuss, let us see the products formed at anode. So, at anode reactions are, what are the possibilities for anode reactions? Since copper electrodes are used, copper electrodes are active electrodes. Active electrodes means atoms from the electrode take part in the reaction, that is lose electrons and enter into the solution. Therefore, Cu solid gives Cu2 plus 2 electrons. Therefore, E0, this is since oxidation takes place, we can write oxidation potential is minus 0.34 V. So this is one possible reaction. So another possible reaction is SO4 2 minus gives S2O8 2 minus disulfate ion plus loses 2 electrons. So here E0 oxidation equal to minus 2.05 V. There is another possibility of anode reaction, that is H2O liquid gives, this is oxygen releases here plus hydrogen. So this is half oxygen plus 2H plus. E0 equal to electrode potential is equal to minus 1.23 volt. So here in all these three possibilities, which has a higher reduction potential, reduction of copper has a higher reduction potential. Since Cu has a higher oxidation potential, higher oxidation potential. Therefore, oxidation of copper takes place. Oxidation of copper takes place at anode. Oxidation of copper takes place at anode. Therefore, during the electrolysis of copper sulfate, when copper electrodes are used continuously, therefore, as the process goes on, continuously, copper cathode becomes thinner. Thicker. Copper cathode becomes thick. That means increases, its size increases. Right. On the other hand, copper anode becomes thinner. Thinner means it becomes lighter and lighter. Weight becomes less. Anode weight becomes less and cathode weight becomes more. Right. If any impurities are present in the copper anode, the impurities like iron, etc., they settle down at the bottom of the solution. Thus, this electrolytic process is also used for the purification of metals like copper and precious metals like silver, gold, etc. And the impurities present at the bottom, impurities settle at the bottom are called called as anode mud or sludge. Now let us see the products formed during the electrolysis of aqueous copper sulfate using platinum electrodes. So, electrolysis of aqueous copper sulfate using platinum electrodes. In place of platinum, we can use even graphite also. So, platinum and graphite, they are passive electrodes. Passive electrodes means they do not take part in the electrode reaction. So, platinum and graphite are passive electrodes. Passive electrodes, that is, they do not take part in reactions, in electrode reactions. Now, aqueous copper sulfate dissociates into Cu2 plus ions and SO4 2 minus ions. Now, electrode reactions. Reaction at cathode. So, what are the reactions? Copper Cu2 plus 2 electrons takes place, forms Cu solid. So, what is E0? E0 cell equal to plus 0.34 V. So, this is the possibility of one reaction. Another reaction is H2O. Water also gets reduces at cathode. Therefore, it takes 1 electron and becomes half H2 plus OH minus. So, here E0 equal to minus 0.41 V. So, here reduction of copper has higher reduction potential, therefore preferably copper reduces at cathode. On the other hand, reaction at anode. So, reaction at anode, SO4 sulfate ions, they release 2 electrons and becomes S2O8 disulfate ions plus 2 electrons, and the electrode potential is minus 2.05 V. This, of course, this is oxidation potential. So, here at the anode, copper does not oxidize because we are using the passive electrodes, that is platinum electrodes. What is the other possibility? Other possibility is H2O liquid 1 by 2 O2 plus 2H plus. Oxidation potential is equal to minus 1.23 V. So what happens here? Since oxidation potential of water is more, since oxidation potential of water is higher. Therefore, water oxidizes to oxygen. So finally what happens as the process is going on, copper ions continuously reduce. As copper ions continuously reduce, the blue color of the copper sulfate reduces or fades away, and sulfate ions are left in the solution itself. Therefore, ultimately, as the reaction goes on, concentration of copper sulfate decreases, and ultimately solution becomes sulfuric acid. Therefore, the final product is sulfuric acid, that is H2SO4. Now let us see the electrolysis of molten sodium chloride. Electrolysis of aqueous sodium chloride using the platinum electrodes or graphite electrodes. Anyhow, during the electrolysis of sodium chloride, we cannot use sodium as electrode because it is a soft metal and cannot be made as rod.
Apart from this, sodium is highly reactive metal and it cannot be made free rod like other metals such as iron, copper, etc. If sodium is kept in open air, it reacts with oxygen present in air and forms oxide. Hence, active metals like sodium, potassium, etc. cannot be used as electrodes.
Right. Therefore, electrolysis of aqueous sodium chloride using platinum or graphite electrodes. Now, sodium chloride aqueous, it dissociates into Na plus ions and Cl minus ions. Therefore, reaction at cathode, Na plus, it takes electron and becomes Na. So sodium takes electron and becomes sodium neutral atom, that is sodium ion reduces to sodium, and electrode potential equal to minus 2.71 V. The other possibility of reaction at cathode is H2O plus electron gives half H2 plus OH minus. So here E0 electrode potential equal to minus 0.41 V. So we know that the ion or atom with higher reduction potential reduces at cathode. Therefore, since the electrode potential of water is higher, therefore water reduces at cathode. Therefore, sodium ions are left in the solution itself. On the other hand, reaction at anode. So reaction at anode, chlorine Cl minus releases one electron. Therefore, half Cl2 plus E minus gives a electrode potential, that is oxidation potential equal to minus 1.36 V. So this is one possibility. Another possibility is water oxidizes to oxygen plus 2H plus. Electrode potential is minus 1.23 V. So as per the convention, water must oxidize to oxygen, but in practice, instead of water, preferably chlorine oxidizes at anode because of the over voltage. So here over voltage also plays an important role. Over voltage makes Cl minus to oxidize at anode. So ultimately what will happen? Chlorine decreases in the solution. Therefore, NaCl solution becomes NaOH. NaCl, sodium chloride solution, becomes sodium hydroxide at the end of the electrolysis. So these are the products formed during the electrolysis of aqueous sodium chloride using passive electrodes, that is platinum or graphite electrodes. Now electrolysis of molten sodium chloride. Now let us see the molten sodium electrolysis of molten sodium chloride. Molten means it is a fused state or a pure substance. So sodium chloride fused, so it dissociates into Na plus ions and Cl minus ions. So there are only two types of two ions, one positive ion and one negative ion. So ultimately oxidation reduction of these ions take place at a cathode and anode. So at cathode Na plus electron, it takes electron and becomes Na plus. There is no competitive ion in this reaction in the aqueous, molten. In the molten sodium chloride or fused sodium chloride, there are no competitive ions to oxidize or reduce at anode and cathode. Therefore, ultimately sodium reduces at cathode and Cl minus oxidizes to Cl2 at anode. So these are the ultimate products when the molten sodium chloride or fused sodium chloride is used in the electrolysis